Okay, we are going to conclude 6.1 and let's go over the key concept of the lesson today. And here we have, look, this is how you convert the rational exponents into the radical form, or vice versa, the radical form into the rational exponents. And that now I will look at page 415. You see a key concept. Understand this right here. You look at this. There we go. Understand this as 1. That will give you a heads up. Now, to bring the radicand A outside of the radical form, simply take this 1 over n. And that's how the radicand has the exponent 1 over n. You see that? Okay, similar to that, now let's look at this key concept right here. What if right now you have, let's say, a radical form of A? Now, what if A right now, the whole thing, okay, the whole thing right now to the m exponent or the m power. Same thing, you see that? 1 over n. Same thing, m over n. There we go. Beautiful. Okay, you see that? For example, if you have right here is, let's say, 3, and then your radicand right here, let's say any number, 7. How about that? Okay, and this is to the power of, give me a number. Okay, 2. There we go. Can you tell me what would that look like when you take 7 out of the radical form? That means 7 what? 2 over 3. Perfect. There we go. That's the simplest form and how you convert from radical form into the rational exponents. Okay. Now you ask, Mr. Deng, what if you have a negative exponents? Then we use the same mathematics properties. Okay, guys. As long as you stand your ground on the principle of mathematics, you still have the same value. What if right now A, okay? What if right now A to the negative m to the n? Wow, what would that look like? Okay, what is A to the negative m over n? Well, we learned from the other chapter, and that is to bring the positive to the exponent. Since you have a negative, what do? Understand that as 1. Now you just bring the exponent down to the denominator. This is equivalent to 1 over A. And now from negative on this right here, you turn into a positive. There we go. We are no strangers for that. Only one thing that you need to be mindful of, and that is thou shalt not divide by 0. Okay, so A cannot be 0 in this case, because if A is 0 in the denominator, that would, destroy the logic of mathematics. So just for the case when A is in the denominator, it cannot have 0. So by that, for example, if you have, let's say, 3 to the negative, let's say 4 over 5. And how would I turn this into the positive? And that is 1 over, one step ahead of you. So this right here, 1 over 3 to the 1/4. There we go. And then you ask, Mr. Deng, what do you mean? What do you mean by, let's say, A to the m over n? What does that equal? Here, look, here you have rational exponents. How do I convert this into the radical form? Well, you know the magical formula, not magical, but the true value, how to convert the rational exponent into a radical form. Look at this right here. There we go. And this is your n right there. You see that, guys? That's your n right there. Okay? And that's your A, and the whole thing, what? To the m power. There we go. So that means if you have, let's say, 3 to the 4 over what? Let's say this is 5. There we go. Can you convert the rational exponents into the radical form for me. I heard some say, piece of cake, Mr. Dang, way to go. So here we go. 3, and what is the n value right here? That's 5. And then to the what? 4 power. Bingo. With that saying, we are good to go with the examples, okay? So would you look at example 2 and example 4 with me? And we'll look at example 2 and 4, and then we will conclude our lesson today, and we'll do a few examples, set you guys up for your example, for your homework on 6.1. Okay. All right. Here we go. You're having fun, guys? Okay, here we go. Example 2 you have right now, and the text asks us to evaluate on A, and that is 16 to the 3/2. There we go. What would that look like? What is the value of this guy look like? And you are now no stranger to the rational exponents. You can choose to do several ways if you want to. Here we go. Let me do the traditional way, what we've been, learning. So here we go. I put them in the radical form. Is that okay? 16 right here. And what is this guy right here? That's your 2, which is square root of 16 all the way to what? There we go. Mr. Dang, notice I don't write 2 right here because you say, Mr. Dang, you are being silly. I know. Just for your sake, I am. So there we go. There we go. Now, let's do one step at a time. And what is inside the parentheses, let's evaluate that. Talk to me. What is square root of 16? Yeah, there we go. 4. Okay, to the 3rd. Now, what's that? 64. There we go. And see? First, take care of the radical form, what is inside the parentheses, and then you would do the exponent later. Okay, please excuse my, remember the operations, guys. What about B? You have now a negative value, okay? The negative exponents. Here we go, -3/5. There we go. What would that look like? Before I evaluate this, I'm gonna make my exponent positive. How do I do that? Okay, remember, 1/32 to the 3/5. There we go. Remember, this is 32 to the whole thing. Okay, then how do I solve this guy right here? Well, do it normally. I'll bring it up here for you, okay? 1/, right here. Convert this into the radical form. Here we go. And that's 32. Now, what is the degree? What is the degree of the index right here? What's the index number? That's 5. Now I write number 5. Why? Because it is more than, it is bigger than 2. So I write that. Now the whole thing to the what power? Don't forget 3. 3 is, there we go. Okay, good? All right. Ask yourself, can I convert or can I express 32 into, really a factor of, let's say, if you divide this by 2, let's say you divide this by 2, you will have, 16, and then so on. You will see 32 is equivalent to 2 times 2 times 2 times 2 times 2. There we go. And combine this expression right here. This is the simplest form. Now you see something. 32 is being expressed as 2 to the 5th power. So I'm going to rewrite that guy right there for you. Okay, 2 to the 5th power right there. And the whole thing right now is to the 3rd power. Perfect. Can anyone see the light here? Oh, Mr. Dan, the 5th radical root of 2 to the 5th, that's exactly what I have for 2. That's inside parentheses, okay? There we go. Okay, and now you have 3 right here. So, can you tell the answer right now for me? The answer right now is 1/. There we go. Okay, all right. That is what I like for you to capture right away. 32. 32 is 2 to the 5th. and 2 to the 5th of a fifth radical, okay, then you will get 2, okay, you get 2. And then noticing the exponent of the whole radical form is 3, therefore 2 to the 3 give you 1/8, and that is your answer right there, okay. All right, you have the guided practice for you. Can I move into example 4 and help you to solve the equation with exponential form in it, okay? All right, let's look at example 4 with me, please. Okay, you can pause the video anytime you want to. Let me move into example 4, okay? Here we go. Example 4. Okay. All right, in example 4, we are asked to solve the an expression that is for a function, okay? The equation right here is 4x fifth equals 128. Okay, here we go. Okay, just, conduct in a normal procedure. You have a constant time of variable equals another constant. So you are asked to find what is that constant. Your constant right here is expressed in an exponential form. So same procedure. You divide both sides by the same value. You would not change any value of the equation whatsoever. And by doing that, you now single out your variable, which is x to the 5th. Now right here, give you the answer of 32. All right, here, my friends, boys and girls, listen to this. X fifth equals 32. Does that look familiar? Ask yourself right here, what is a number to the 5th power give you 32? And you guys can do this right here. Here is the mechanic of mathematics, the explanation, okay? How do I find the value for x here, Mr. Dan? Big move right here. We're about to make big move. Look, to find the value for x, I need to take the x to the 5th just by itself. How do I find that? Look, I am going to take the 5th radical root, the 5th root to both sides. There we go. You see that? That's the technique. And this is the big potato that we learn from the equivalent of rational exponents in the radical form. I am doing one thing to both balanced equation. I have not changed anything. The purpose, I take the 5th root is to find the single value for x. By doing that, I am now see that this left side right here, guys, you see that? And that bring down to the value for x. There we go. That's it. That is the purpose. I take the 5th root. Okay. Now let's solve for the right side. Now I got what I want. I need to know what is the value for x right here. So you are now can go home from right here. Can anyone tell me what is the 5th root of 32? Perfect. The 5th root of 32. I can rewrite that as right there. Okay. And that is what? And that is 2. Perfect. Bingo. Okay. Makes sense? You ask, Mr. Deng, what if you have, let's say, what if you have x to the 3rd equals 8? What if? I'm just giving you a concept so you capture this now. What if x to the 3rd and then that's equals 8? How do I find x, Mr. Deng? I mean, you can do mental math, but just here is the mechanic of mathematics for you, okay? To find x right here, what do you do, guys? You take the 3rd root of both sides. There we go. And that bring you down to this left side right here is x right there. Whatever you do to get rid of the exponent. If this is 3, then you do the 3rd root. If this is 5th, you take 5th root. This is 10, you take 10th root, okay? So that will bring you down to this is 2. Perfect. Okay, I hope I make myself very clear right there. Okay. All right. I know I'm not insulting your intelligence here. Okay, I hope not. I, I hope so. Okay, here we go. You have the next example, and that is example B. Okay, here we go. We have a linear expression right here, and that is linear expression to the fourth power equals what? 21. This is fun, guys. This is fun. You might look at this and say, Mr. Dang, what do I do here? Well, guys, look, some problem looks strange doesn't mean it's hard, okay? And some problem looks familiar does not mean it's easy either, okay? But this one looks a little bit strange to you. Stand on the principle. Say with me, stand on the principle, okay? Got it? Now, I need to solve for x. Wow, what shall I do, Mr. Dang? Look right here, y'all, look. This all together inside parentheses, okay? So I see that it's one entity right here. I need to get rid of 4. There we go. Ask yourself, I need to get rid of 4. What shall I do? Same technique as you get rid of 3. Same technique as you get rid of 5. Yep, I saw your thought. Good. What do? You just simply go ahead and take what? You go ahead and take the 4th root. Take the 4th root of that parenthesis. If you do 4th root on one side, what do you do to the other guy, to the other side? That's right, 4th root right there. Okay, are we good here? Okay, is it a fair game? Have I changed anything? Nope. Because of that, this is the beauty of mathematics. You do one thing to both sides, which are already in perfect balance. You have not changed whatsoever. But by doing that, you can solve for x. And that's how physicists and scientists, they explore and they write equations and formulas, okay? So here we go. By doing that, you now see this guy is gone, okay? And that guy is gone, and that now you have whatever inside this. Remember I said this is one entity. It's like 1a, okay? So my a right now is right here, okay? That's x minus 3. There we go. The 4th is gone because 4 over 4 is 1, technically. So now you have over here, but Mr. Dang, I don't know what is the 4th root 21. Well, if it's not perfect, leave it there because this now is in the, perfect and simplest form. I like to bring you to your attention. Remember, Mr. Dang told you on the key concept. If you have an even root of a radicand and the radicand is positive, then please notice something. Remember, if this guy right here, suppose this is square, okay? Square root of 4, what you get? Positive and negative 2. Got it? Same thing. What about square root of, let's say, 7? Okay, the square root of 7, the outcome right here you will have is both what? The idea right here, I am trying to give you the concept of the radical root right here and trying to explain to you why these guys have 2 values right here. You see it? We use this one first, you can see. So when I do this even root right here of a radicand, when the radicand is positive, then how many values shall I have right here? There we go, positive and negative. And since I don't have a perfect square, a perfect root, 4th root for this guy, keep it that form right there. Okay, we cool? All right, now the next step is just a piece of cake for you right here. If x minus 3 equals plus minus the 4th root of 21, what would be x? Here comes. You will just solve for x by adding both sides to what? To 3. And that will cancel out. The answer right now you have is x equals plus minus 4th root of 21 plus 3. There we go. Okay, and I boxed this one for you. And now you can see. Okay, well, technically, use your calculator. You will have 2 values right here. Okay, 2 values. If x is a positive, the 4th root 21 plus 3, you have two values. If x is positive, the 4 through 21 plus 3, and that will give you 5.14. Then if x, or if you use the value for x equals negative 4 through 21, of course you will have right here a lesser value, which is 0.86. There we go. Ladies and gentlemen, you have two values, and both of these values perfectly satisfy your function. What function? The function is right here. Okay, the function is right here, and there we go. That's your function right there. That's what it means, guys. These two values, when you plug into your original function, it brings perfect equivalent value to both sides. You plug 5.14 in here, you got 21. You got this one in here, you got 21. Okay, if we use the decimal, perfectly. All right, with that saying, we now done with example 4. Let's do example 5, and then we conclude here, okay? All right, let's look at example 5. Example 5 is when you are now using the rational exponents to put into the real life application, okay? All right, in this problem right here, we are looking at the weight, W-E-I-G-H-T, the weight of a type of a fish by the name coral cod. Can we call it Nemo? Okay, we are looking at the example of finding the weight of Nemo. All right, here we go. We know that some type of fish in, let's say where, in Philippines, and there is a relationship between the weight and its length is in this way. W stands for the weight of the fish, and then the constant here is 0.167, and then the length, okay guys, length, that's the length of the Nemo, the fish, okay, to the third power. Noticing that you are dealing with the rational exponents, and this is here, L to the third power. This is the weight of the fish, this is a constant, and L stands for the length, L-E-N-G-T-H. Okay, how do you know? This is another way to say the relationship between the weight and its length based on, the nature of the fish named coral cod. Okay, here we go. And the textbook gave us that what if they gave us the weight, and if the weight right here, if the weight given to you is 200 grams or kilogram, 200 grams, okay. Well, kilograms is too much. 200 grams, okay? Then 200 grams. Then what would be the length of the fish? Okay, this is now, you just plug the value in. This is given to you, okay? And this is the nature from observation. This is math people do, you and I do. This is how you draw an observation. You see every type of fish from small to big of the coral cod. It is related from its weight and its length, okay? So if the weight of that fish is 200 grams, then what is the length? Simply plug it in. Okay, here we go. You have 200 equals what? 0.0167 and L to the third. All right, ladies and gentlemen, if the L bothers you, but don't let that bother you. You can put X if you want to, See, right there, X, finding for X. X stands for what? X stands for L. L stands for the length. L stands for there we go, the length of the fish. So the technique is same procedure right here. You divide both sides by, that's right. Here we go. Okay, there we go. So now you have X third equals, I just rewrite this, 200 divided by whatever number right here, what you have right here. And then using your calculator, I'll let you use your calculator, 11,976. Okay, guys, the length to the third power equals that. Asking you what is the value for X. Okay, again, we need to find X, right, guys? I need to find x alone, Mr. Dan. How do I solve for that? See, this is how we convert what? Rational exponents into radical form, vice versa. To get rid of the third power, what do I do, guys? That's right. Take the third root of both sides. Ladies and gentlemen, use red ink. Looks scary. So there we go. Ha. Oh. Don't forget, Mr. Dan. There we go. By doing that, my x to the third power disappeared. What I have right now is just x. And then punch in. See, I missed something? Careful. A lot of students forget to put 3 right there, including Mr. Dan. See, because if you take the third root on one side, you have to be, equivalent, have to be fair to the other side. Because if you take square root, you still get a value, but it's not the true value. Therefore, equivalent, same thing to both sides will give you the true values of the original function. And then using your calculator, you will have 22.9. There we go. That is the length, guys. 22.9. The length is in inches, or I believe it's in, let me see. Yeah, centimeters long. There we go. Centimeter. There we go. Ta-da. Okay, guys. I think we are done with example 5, and that is your application. And the rest, I will put homework on RenWeb for you. Hey, have a wonderful day. Miss you and pray for you all. Until next lesson.